Firstly, I'd like to say that I've always had a strong passion and interest in aviation, from hang gliders right up to jumbo jets. Through the years, I've tried to stay current with new developments in this field. One of my greatest concerns has always been witnessing air disasters while being aware of our inability to help a stricken aircraft in any way.
The project was introduced to me by Rommel and my partner in Concept Reality in the middle of 2005. Rommel came to me with a new idea which is not unusual considering the line of business that we're in developing new concepts and ideas. I could tell, however, by Rommel's enthusiasm that it was a project that he'd had on his mind for quite some time.
I never thought I could resolve such a complex problem on my own, but with the formation of Goldfinger Aviation and the hard work of our staff, that's exactly what we're now trying to achieve.
The idea was for a new aircraft design with passenger safety as its emphasis. The idea totally blew me away. It's not every day, even in our line of business, that you have the opportunity to work on a project or even be shown a project that has the ability to change an industry of this magnitude or the future of this industry.
My first involvement with aviation safety concepts can be traced back around 20 years ago, when I had the idea of using giant parachutes for airliners. But after analysing the concept over the following year, I realised it wasn't feasible for a number of reasons. After that, I began considering a system where the upper half of a plane could separate from the lower half and glide automatically and independently. The bottom half, which is the heavier half containing the main engines, fuel and standard undercarriage, would be jettisoned.
Once Rommel approached me on the project, we thought it was necessary for us to separate this project from our existing enterprises. As such, we decided to incorporate a new company by the name of Goldfinger Aviation as the operating company for the research and development of the aircraft safety system. We did this in the middle of 2005. We also then lodged the original provisional application for the project itself.
In 2004, I started to see a much stronger interest and consequent higher financial investment in solutions to the problem of plane crashes. Despite improvements in jet engine technology, dynamic modelling and other areas. As a result, in 2005, I decided to be directly involved in finding a solution and lodged a patent for our developing technology. Through this patent, we plan to submit different configurations of the technology for 10 or more popular types of aircraft.
After 30 years of experience in the aviation industry with Qantas and Alitalia, this is the first time we've seen a project totally focused on improving passenger safety. Over the last few decades, aircraft has greatly improved in terms of efficiency, fuel consumption and comfort. But only now do we see a project which purely aims to improve the safety of passengers. And it is for this reason that it should be strongly supported by airline companies.
I first met Rommel and William approximately 4 years ago when they approached Freehills with a couple of inventions. One related to a multi-directional drill bit and the other to a self-propelled watercraft. And even at that early stage, I was impressed by the level of ingenuity and the engineering skill which they brought to bear on both of those products. It must have been just over 18 months ago that Rommel and William approached me with a number of drawings showing an aircraft which could split in two. I took a look at those, we had a number of consultations, they provided me with additional drawings, and we filed a provisional patent application in August last year, that's 2005. In the months preceding the filing of the international application, I was provided with a large number of different drawings and descriptions illustrating approximately 25 or more different embodiments of the invention. And I began to realize that potentially this could be more than just a paper invention. Normally when a PCT application or international patent application is filed, an international search is conducted by the searching authority, and the results of the international search that were conducted appear to be encouraging in that there do not seem to be any documents which were located which directly anticipate or read on to Romulo's invention. And this is very encouraging from a patent attorney's perspective, because it means that, assuming that nothing else of significance is found, the chances of getting valid patent protection are relatively high.
It was at this stage that we sat down and put a plan together for the sort of team that we needed to assemble for the initial part of the project. After numerous meetings, we had the pleasure of meeting a group from Heggies who had the experience necessary to assemble such a team. They showed us that they had the ability to assemble an engineering group with the specialties to cover all the areas that we needed for the initial phases. It was during these meetings that we found the company that we wanted to work with in the initial stages of the project.
The company was founded in 1978. We've been going almost 30 years. Primarily we began as an acoustics and vibration consultancy, but over recent years we've now expanded our services into air quality and wind engineering. That's brought a lot of aeronautical engineers into the company. We do quite a lot of wind tunnel testing on buildings and structures. The skill sets these people have brought to the company include finite element modelling, modal analysis and solid modelling, and these design skills have enabled us to contribute in a very meaningful way to this project.
My first contact with the project was when I was asked by our chief engineer Vince Capizzi to come to a meeting to be told about the project and to make a decision on behalf of the company as to our involvement. Naturally, like everyone else, I was surprised when I found out what the concept was about, but only after the second meeting that we had with the project, the kind of engineering expertise that was needed to get the project through, at least past the concept stages, were areas where we could contribute. And I quickly came to the conclusion that this was going to be a very challenging project that our engineers were going to enjoy working on.
We knew on a project like this that there were going to be numerous challenges ahead. One thing that pleased us about Heggies is that they were just as excited as we were about meeting those challenges and also overcoming them.
Essentially, it's a device that takes into account different configurations of aircraft that gives the passenger an option, should something happen, to find a safer alternative in terms of an emergency situation. So what we've got here is an aeroplane that can separate, and should something happen, then the top half, which has all the passenger sections, will separate, leaving the bottom half where all the weight is and all the fuel and all the electronics will be ditched, basically. But it's the full aeroplane still having its full capabilities to arrive at a safe landing position, whether it's on water or on land.
So I think it's a minimization of the risk and optimization of the of trying to save lives, basically, by changing one aircraft into a simpler, smaller, lighter aircraft. The two bodies joined together could make many flights without any emergencies and without anything going wrong. But if one flight's got a problem and there is the need to separate in order to save the passengers, that will be a one-off thing.
A lot of work's been done in the area of separation, and what we see is that it's a very complex area. It totally involves the bodies, the shape of the bodies themselves, and the airflow around the bodies. So if there's any sort of turbulence or disturbance, it might cause the upper or lower aircraft to go into an oscillation, or it might cause a yawing or pitching moment, which could endanger one or the other aircraft as they're separating. So it's a very difficult sort of technology to come to grips with, but it's the subject of many similar type applications, say in defence where they release bombs or fuel tanks or whatever. Got to make sure it happens safely.
Well, there's several aerodynamic issues that are associated with this concept. The biggest and most predominant one is simply that if you have two bodies separating at different points during that separation, they have very complex aerodynamic interactions with one another. So our main tests comprised of testing our design at different stages of separation, that being both different separation distances, different separation angles and positions relative to one another, because at all these different times and occurrences, different things are taking place aerodynamically, different forces are imposed on the bodies. So we had to do a lot of work, both computationally and experimentally, on trying to gauge what these forces were doing, how they would change, and use that information to try and gauge whether it was possible for these bodies to separate safely and be used in the planned manner.
The Sydney Uni tunnel, first of all, we looked around, we looked at some other organizations or universities, and that was definitely the only one standing out in terms of wind velocity, in terms of size as well, which was a critical requirement, and availability as well, cost, and also support we could get from the uni. So we were lucky enough to find all this package at the Sydney Uni.
My name is Aviation, and I work for Hackey's Australia. My main role is to transform a concept from a sketch on the paper into a CAD model that can be used to produce prototypes which can then be tested and validate our concepts.
Okay, the way we construct a wind tunnel model is usually we make a computerised model of it on a computer using CAD systems. That's usually based off our previous work on the design. We use those to proceed on to making a wind tunnel, a scaled wind tunnel model of that. It was designed to be manufactured in different parts and machined out of plastic. All the different parts were returned and assembled. And these could be assembled at the wind tunnel along with equipment and sensors and all the mounting equipment necessary to place it in the wind tunnel.
The first issue was, it wasn't an issue, but it was just a learning curve, as in using the tunnel, because it's not only pressing a button and you get the wind going inside the tunnel. So I had a bit of a training before actually getting started. That was the first phase. The second phase was actually getting the model ready. I wasn't part of the design of the model as such, but I did all the design of the support system, which will enable to attach the model and change the configuration of the model inside the tunnel. So it was a bit of a design phase, and also supervising the manufacturing, which was done here in Sydney, and just consisted in brackets and plate elements that would have to be attached accurately so that the model will be supported inside the tunnel. Will also achieve different configurations in terms of angle of attack, and so the brackets were modular, and we could achieve any angle of attacks and any pitch and roll differential angles between the two bodies inside the tunnel. And once the two-body model was in place, then we ran approximately a week of testing, knowing that each configuration was done for different wind speed, for different angle of attacks, for different relative angles between the two bodies. I think at the end of the test we've got more than 250 configuration tested. We've got pressure data, we've got relative forces between the two bodies, and we've got overall forces of the entire system. So it's a lot of data, but it gives us a lot of information about how the body and how the aircraft behaves and reacts in different configurations.
Mm-hmm. For a normal aircraft, the aerodynamic forces being applied, especially in the form of lift, are quite large. In fact, the lift forces are holding the aircraft up entirely. So if you have a 200 or 300 ton aircraft, and you have 200 or 300 tons of aerodynamic lift force being applied to the wings and the body. Now, if those forces change suddenly due to a geometric change in the aircraft shape, which is what is occurring as the body starts to separate, then the lifting mechanism, the thing that's holding the aircraft in the air, is rapidly changing as well.
And what we found was that the influence of the upper fuselage was paramount in the way it's separated. And we also found that there are a lot of coupling effects occurring, because, you know, in one instance we would find wings sticking together, whereas the fuselage might be wanting to separate. So we need to get to the bottom of all that. But it just explains or presents the complex nature of the aerodynamics involved. And we didn't see any surprises, so to speak. We expected separation to occur at particular angles of attack and attitudes and wind speeds, and we actually found that correlation.
All the results we've achieved during Phase A and the wind tunnel testing has been very promising. All the data we've gathered has proven the feasibility of the project. As such, it's given us great confidence in moving forward to the next phases.
The beauty of the whole thing is that it doesn't look like a different aeroplane. The efficiencies attracted with one aeroplane are still there, and yet when they're separated, we can still get those same sort of efficiencies for the individual aircraft. We don't get to do this every day, and we feel that this is something that, how do you say it, initiates a new way of thinking about aeroplanes, and therefore we're excited to do this sort of stuff, and we're very happy to support innovative ideas in this area.
One of the other pleasing aspects about our involvement in this project is, as a result of our early involvement and the very close working relationships that have been fostered by the Goldfinger directors on this project, our engineers have had a unique opportunity to see how an idea develops from concept to market reality, not just from a technical point of view. Our staff has witnessed the development and protection from legal points of view of the intellectual property associated with this concept. We've also witnessed how the commercial aspects and the aligning of commercial partners has progressed, without which this idea would never get from concept to market reality. So we've had a unique view on how this project is progressing, not just from a technical point of view.
We're packing more into an aeroplane, but we're making it inherently safer.
Why would I do this? My dream is to see this technology implemented in future aircraft and become a part of aviation history.